Hi everyone and welcome to another video, and today is going to be a continuation of the topic of projectile motion. So I've already created a first video, an introduction to it, and you can check that out from the link that I'll share above right here. So today we're continuing with the topic, and today we shall be looking at horizontal projection. This is another key part of projectile motion. Alright, so make sure to get your notebook and follow along with every single example that I'm going to be giving each one of you. And then when there's going to be an exercise at the end of it, and I encourage you to do that exercise and compare your answers to the ones that I'll be giving you right there. Alright, so without wasting time, let's learn horizontal projection. Alright, so today we'll look at horizontal projection. So we'll look at a case where a projectile is launched with an initial velocity from an elevated position and follows a parabolic path to the ground. So when a particle is projected horizontally, its angle of projection is 0 degrees and its initial velocity in the vertical direction is 0. So therefore this means its horizontal acceleration is 0, since gravity is the only force acting upon it and it has a constant acceleration of g downward. So the particle no longer follows a straight line downwards as shown below. So look at this particle, for example. So it's actually projected from a point above the ground, as you can see right here. So this is more of an elevated position. So this can be a cliff, a wall, a building or something, but it's actually projected from the top. And as you can see, when we project it horizontal. So that means that the angle of projection is basically 0 degrees. Alright, so there is the U, and then right now we shall consider the Y. So the Y is the height of the elevation basically, and then we're going to have the X. X represents that horizontal displacement. And then V is going to be the velocity at any point, and of course alpha there represents that angle of projection. During the velocity after the particle has already been projected. Alright, so Y is the height above the ground, X is the horizontal distance covered by the projectile, U is the initial velocity, and V is the velocity at any point after projection. Since the particle is given a horizontal velocity, it means theta is 0 degrees. So therefore, if we look at the horizontal motion, in the horizontal, the acceleration component AX shall be equal to 0 meters per second squared. So the horizontal component of the velocity UX shall be equal to U cos 0 degrees. That is because now we don't have a theta value. Our theta value shall be equal to 0 degrees. And we know that cos 0 is basically 1. So we'll have UX being equal to U meters per second. So from first equation of motion, which is V is equal to U plus AT, we can actually see that Vx is UX plus AXT. So when we substitute in the theta as 0, so we'll have there a 0, and remember that AX shall be equal to 0. So therefore we shall remain with Vx being equal to U cos 0, which is basically U. So Vx is basically going to be equal to U, and that's going to be our equation 1. And then from the second equation of motion, which is S is equal to UT plus a half AT squared, we shall actually convert S to be equal to X, U to be equal to UX, A is equal to AX. So when you substitute those in, this is what we have. But remember that theta value is basically represented by 0. So basically we end up having X being equal to UT. And that's going to be our equation 2. So when you look at the vertical motion, we remember that at the point of projection, the vertical component of velocity is 0. So Uy shall be equal to U sine 0. But you know that sine of 0 is 0. So therefore Uy shall be equal to 0, because 0 times U is 0. So this is because the motion is purely horizontal. So the vertical component of the acceleration Ay is equal to g meters per second, and that's because right now we're looking at the particle basically acting downward under gravity. So since the particle is moving against gravitational force, that's why we have Ay being equal to g. So from first equation of motion, V is equal to U plus AT, we can actually see that Vy shall be equal to that. So where there is Uy, we remember that now Uy is actually 0. And that's basically what we have right there. So now we shall end up having Vy to be equal to gt, and that's going to be our equation 3. And then from the second equation of motion, we remember that s is equal to ut plus a half at squared. We're going to substitute in those values. Then we shall have y being equal to u sine 0 t plus a half gt squared. But remember that sine of 0 is 0. So 0 times ut is 0. So we'll end up remaining with y is equal to a half gt squared. And this is going to be our equation 4. So now, basically, all these equations that I've actually highlighted, the equations 1 up to 4, are basically formulas that I encourage you to memorize because they'll be helpful as you get close to our calculations. Now, from equation 2, remember at equation 2 we said x is equal to ut. We can see that if we make t the subject, t shall be equal to x over u. So substituting for t in equation 4, we shall actually see that y, we know that y is equal to half gt squared. So when we substitute the value of t there, we shall actually see that y shall be equal to g x squared over 2u squared. So let's work on that, and we shall actually see that y shall be equal to g over 2u squared bracket x squared, and this is the equation of trajectory in the horizontal projection. How about if we look at the velocity of the particle at any instant v? How do you work on that? So we know that vx is equal to u cos 0, but we know that cos of 0 is 1, so vx is u. So also remember that vy is equal to u sine 0 plus gt, and then we remember saying that vy is equal to gt. So now to find the velocity of the particle at any instant, remember that v shall be equal to square root of vx squared plus vy squared. So to get the direction, which is alpha, tan alpha shall be equal to vy over vx, and then alpha is basically equal to tan inverse of vy over vx, and that's how we find that direction. Alright, let's look at some quick examples, and this will actually enable us understand this even much better. So in question 1, we're being told that a projectile is fired horizontally from the top of a cliff 500 meters high. The projectile lands 8,000 meters from the bottom of the cliff. So find the initial speed of the projectile. 2, the velocity of the projectile just before it hits the ground. And that's what they're asking for. So let's solve this. But as we do that, the best thing to do is to actually first sketch this. So let's actually sketch our projectile. So we're being told it's fired horizontally. So definitely this is horizontal projection. And then we're being told that, so we know what u is, and then we're being told that the projectile lands 8,000 meters from the bottom of the cliff, and that's how we actually label 8,000 meters. Then we've also been told that the top of the cliff is 500 meters high. So now we're going to place the 500 meters as the height of the cliff. Then v is basically the velocity at any point of during the projection. So now we are basically being told to find the initial speed of the projectile. So that means we are looking for the value of u. So now we're going to be making use of two important formulas, and that is going to be the formula of y and the formula of x. And those are going to be the most useful ones. So for this case, we remember that from x is equal to ut, remember this formula for x. So now we can actually see that since we know what the value of x is, so ut is equal to 8,000. That's going to be our equation 1. And then right now, the next thing that is wise to do is simply, because we have this unknown here, now we are looking for u, but we also don't know what the t value is. For right now, we also know that for the t value to actually when we're dealing with the full horizontal projection until the point it lands, that value 8,000, this t actually is referring to the time of flight. So now to find the time of flight t, we're going to use the other formula, that y is equal to half gt squared. Now we know what y is 500, and definitely we know that gravity is going to be equal to 9.8. So we can actually first find the time of flight. So 500 shall be equal to 4.9 t squared, and then you can actually say that t squared is equal to 500 over 4.9. Then t squared is 102.04. Then when we find the square root of that, t shall be equal to 10.1 seconds, and that is our time of flight. So that now that we know the time of flight is 10.1 seconds, we can substitute that into equation 1. So now we shall have u times 10.1 being equal to 8,000. So therefore u shall be equal to 8,000 divided by 10.1, of which u is equal to 791.96 meters per second. So therefore the initial speed of the projectile is 791.96 meters per second. Now in part 2, we're being asked to find the velocity of the projectile just before it hits the ground. So we found the time of flight as 10.1 seconds, and that's going to be very important. So now next we have to first find Vy. So Vy shall be equal to gt, and we already know that. So gt, we already know that the time of flight at the moment that the particle hits the ground, that means that the time of flight is the time that we are looking at. So we're going to multiply 9.8 times 10.1. So when we do that, the product is going to be equal to 98.99 meters per second. Then we're going to need to find Vx. So Vx is equal to u, and then we already know what u is. We've already found that initial velocity, it's 791.96 meters per second. So to find v, remember that v is going to be equal to the square root of vx squared plus vy squared. Then we can basically, we just substitute those values in, and then we end up having the square root of this value, which is going to be equal to 798.12 meters per second. So let's find the direction of the projectile also at that moment. So alpha shall be equal to tan inverse of Vy over Vx, of which tan inverse of that shall be equal to 7.12 degrees. So therefore the velocity is 798.12 meters per second, acting at an angle 7.12 degrees to the horizontal just before it hits the ground. So question number 2, we're being told that a transport plane traveling at a steady speed of 50 meters per second at an altitude of 300 meters releases a parcel directly above a point P of the level ground. So find the time taken by the parcel to hit the ground. Part 2, the speed of the impact of the parcel. And then part 3, the distance from P to the point where the parcel hits the ground. So let's solve this, but let's first sketch this. So there we have the point P. The point P is where the plane was, so it's at height above the ground. So the height above the ground, the altitude is 300 meters, and then you can actually see that the speed of projection is 50 meters per second. And then now x is unknown, we don't know that horizontal distance. And then we're going to place our v value right there. So now let's find that time taken by the parcel to hit the ground. So now we know from y is equal to a half gt squared, because we already know what the value of y is, so we can use this formula to actually find the time of flight. So we can actually see that 300 shall be equal to a half times 9.8 t squared. So now when we do this, we shall have t squared being equal to 300 divided by 4.9, which is equal to 61.224. Then find the square root of that, we shall actually see that t shall be equal to 7.825 seconds. So therefore the parcel will take 7.825 seconds to hit the ground. So now in part 2, we're being told to find the speed of the impact of the parcel. Now we have to first find, that means we have to deal with Vy. So let's first find what that V is. So now looking for V, but let's first find Vy. So Vy is equal to gt, of which we have 9.8 times 7.825. So remember that right now we're looking at impact, so that means we are looking at the time of flight. So that's why we use the 7.825 seconds, which is equal to 76.68 meters per second. So let's also find Vx. Vx shall be equal to u, of which that is equal to 50 meters per second. Now when you find v is going to be the square root of vx squared plus vy squared, of which when you calculate that, you should actually see that v shall be equal to 91.54 meters per second. Alright, let's also find the direction of the projectile. So you should actually see that now we have tan inverse of that, which shall be equal to 56.89 degrees. So therefore the speed of the impact of the parcel is 91.54 meters per second, acting at an angle 56.89 degrees to the horizontal. Alright, now in next one we ask to find the horizontal distance from P to the point where the parcel lands. So now we can use x is equal to ut to find horizontal distance, because actually we don't know what that x value is. So let's find that horizontal distance. Now we already know what u is and we know what the time of flight is, so this shall be possible. So x shall be equal to 50 times 7.825, which shall be equal to 391.25 meters. So therefore the distance from P to where the parcel hits the ground is 391.25 meters. Alright, so moving on to question number 3. So in question number 3, we're being told that a ball rolls off the edge of a table top 1 meters high above the floor with a horizontal velocity of 1 meters per second. Find the time it takes to hit the floor, the velocity when it hits the floor, and then the horizontal distance it covered. So let's first sketch this. So this is basically what we have. So this is so we're being told that that ball is actually 1 meters on the table. So the table is actually 1 meter high. So that's what we have. Then the velocity is 1 meters per second. So now x is unknown. We don't know that horizontal distance covered, and then we're just placing our v value for the velocity at any point. So right now we need to find the time that it takes to hit the floor, but we're looking for that, but we already know what the y value is. So now therefore we can use the formula for y is equal to a half gt squared, and we can first find the time of flight. So you have 1 is equal to a half times 9.8 t squared. So 1 is equal to 4.9 t squared, and therefore t squared is 1 over 4.9. Of course the answer from there is 0.204, and the square root of that is 0.45 seconds. So therefore the ball takes 0.45 seconds to hit the floor. Now in part 2 we're being told to find the velocity when it hits the floor. And how do we do that? Now we're going to first find Vy. So Vy is equal to gt, and then we have 9.8 times 0.5. Now basically, because we're looking at that speed when it hits the floor, we're dealing with the time of flight as our time, which is 0.5 as we've just discovered. So now Vy shall be equal to 4.43 meters per second. The next we have to find Vx. Vx shall be equal to u, of which u is 1 meters per second. Then for finding v as usual is the square root of vx squared plus vy squared, of which we shall have that, and then we have the square root of 20.06, which is 4.54 meters per second. So therefore the direction of the projectile can be found as tan inverse of vy over vx, which is 4.43 over 1, of which the answer we shall get for alpha is 77.28 degrees. So therefore the velocity when the ball hits the floor is 4.54 meters per second, acting at an angle 77.28 degrees to the horizontal. Alright, so next we have to find that horizontal distance covered. So now how do we do that? We're going to use x. So x is equal to ut, and then we already know the time of flight, it's 0.45, and then 0.45 times 1 shall be equal to 0.45 meters. So therefore the horizontal distance it covers is 0.45 meters, as easy as that. So moving on to question number 4, we're being told that actually now this is slightly more unique, but this is also easy. So the top of a vertical tower is 20 meters above the ground level. When a ball is thrown horizontally from the top of this tower, it first hits the ground 24 meters from the base of the tower. By how much does the ball clear a vertical wall of height 13 meters situated 12 meters from the tower? So I believe it's asking for that velocity with which the ball hits the wall. Alright, so let's first sketch this and see how it will be represented. So now this is basically what we're looking at. We're looking at the ball being projected from this vertical tower right here, and as you can see it moves, and you can actually see that it actually narrowly clears a certain wall, and this is the vertical wall that we're looking at that actually clears. So now we can actually see that our initial velocity is unknown, so we're going to label it as u, and then the height of the vertical tower from which it's being projected is 20 meters as given in the question. Then we can actually see that we've also been given the horizontal the horizontal displacement from the point where it's projected to the point where it lands, because we've been told that it first hits the ground 24 meters from the base of the tower. So that means we've been told that it will hit the ground at a distance 24 meters from the base of the tower. Then we are also being told that now that the tower, this wall here is 12 meters away from this tower. So that's what we label. Then you can actually see that the height of that wall is 13 meters. And then that's basically what we're going to be working with. So how are we going to do this? So now basically we're going to first find the time of flight t, so that we can determine the initial velocity of u. So remember that y is equal to a half gt squared. So we're going to use this to find that time of flight first. So now we know what y is. Y is 20, so we have 20 being equals to a half times 9.8 t squared. So 20 shall be equal to 4.9 t squared, and then t squared is 4.08, of which t shall be equal to 2.02 seconds. So now we know what our time of flight is. So now we can use this into the equation, the formula of x, to find the value of u, because you already know what x is. So now to find the initial velocity u, we know that x is equal to ut. So we have 24 is equal to 2.02 u. So u shall be equal to 11.88 meters per second, as you can already see, because that's the value you get from dividing 24 by 2.02. So to find the time it takes to clear the wall, we know that x is equal to ut. We're going to be making use of this formula again. So this is the best formula to actually use to find the time it takes to clear the wall at this point. So now 12 shall be equal to 11.88 t. So therefore t shall be equal to 1.01 seconds. So it takes 1.01 seconds for that ball to actually clear the wall. So to find the velocity with which the ball clears the tower, now we can first find Vy, of which Vy is gt, and basically right now we know the time it takes until the ball clears the wall. So now we shall have 9.8 times 1.01. So we now have to use the time it takes for the ball to clear to hit that wall. So that's 1.01. So now we'll have 9.898 meters per second. So to find Vx, we know that Vx is equal to u. So we know that should just basically going to be equal to 11.88 meters per second. So now to find V, we know that V shall be equal to the square root of Vx squared plus Vy squared, which shall be equal to 15.46 meters per second. Then let's find the direction of the projectile. So we have alpha being equal to tan inverse of Vy over Vx, of which now we have it being equal to 39.8 degrees. So therefore the ball clears the wall at a speed of 15.46 meters per second, acting at an angle of 39.8 degrees to the horizontal. Alright, so now we move on to the next example. So in the next example, we're being told that two vertical towers stand on a horizontal ground and are of height 40 meters and 30 meters. So a ball is thrown from the top of the higher tower with a speed of 24.5 meters per second and just clears the small tower. So being told to find the distance between the two towers. Now next we're being told to also find the distance between the smaller tower and the point on the ground where the ball first lands. Alright, so next now we can actually try to solve this. Now this example is slightly different from the one that we've actually just done before, and the difference here is we've not been given the distance between the two different towers in this case, or between the tower and the wall. So now that is going to be a unique one, but let's first label the values that we've been given. So now we know that the initial velocity is 24.5 meters per second. The height of the tallest tower is 40 meters. The height of the smaller tower is 30 meters. And then we also don't know the total horizontal distance from where the ball is thrown from the first tallest tower to where it actually lands. Then we also don't know the distance between the two towers. Then now we also don't know the distance behind the small tower to the point where the ball lands. But basically, we're going to label the distance between the two towers being equal to A, and then the distance, the total horizontal displacement to be B up to where the ball lands, and then this distance here remaining behind the small tower is actually going to be B minus A. Alright, so now what are we going to do here? Now this is going to be a slightly more unique example. So how are we going to do it? Because right now we don't know the time it takes for the ball to reach the tower. Then we also don't know that horizontal displacement between the tower and the ball. So what are we going to do? So basically we're going to divide this basically right here. So we're going to divide, and then we're going to consider the horizontal projection around this point here. So we're going to consider the horizontal projection from where the ball is thrown up to this point here, so that we can now easily find this x value. And let's first find the time it takes for the ball to reach the tower from that point. And now we can basically see that the height right here shall be equal to 10 meters, and that's going to be the difference between the tallest wall and the shorter wall. So we're going to have the 40 minus 30 to get this height right there. Right, and basically we're going to deal with that portion. So we're going to find the time taken for the ball to reach the smaller tower. So we already know that height y is going to be equal to 10, and then we're going to find that time. So now we're going to put 10, and then we can actually see that a half times 9.8 is 4.9, so we shall have 4.90 squared. And then t squared shall be equal to 2.048, of which t shall be equal to square root of 2.0408, of which t is going to be equal to 1.42857 seconds. So therefore it takes a 1.42857 seconds to move for the ball to move from here to the tower. Right, now that we have that time, now we can now easily calculate this displacement here, and we can find what A is and answer the first part of the question. Right, so to find the distance to the smaller tower from the taller tower, we can now use the formula x is equal to ut. Now that we know that time, so we can let A, so we can find A as, so x, the x horizontal distance we're now looking for is A. So we already know our initial velocity is 24.5, so we're going to put that there. And then now we've also found the time it takes until the ball reaches the smaller tower, which is 1.42857 seconds. So when we multiply those, we get A as being equal to 35 meters. And that's basically what they wanted in the first question. So therefore, the distance between the two towers is 35 meters. All right. So now, right, so in the next second part, we're being asked to find the distance between the smaller tower and the point on the ground where the ball first lands. So basically, we are looking at this distance here behind the smaller wall. So now the ball lands here, and this is the smaller tower. So basically, we're being asked to find this distance, B minus A. But before we do that, we have to first actually know what B is, because we know what A is, but we don't know what B is. So let's first calculate B. So we're going to first find the time of flight and the total horizontal displacement of the ball where it first lands. So now from y is equal to half gt squared, we're going to use that to find the time of flight, the general time of flight. So now we know that the height of the tallest wall is 40. So we're going to multiply that, and we shall have 40 being equal to 4.90 squared. So t squared shall be equal to 8.1633, and then therefore t shall be equal to square root of that, of which it's going to be equal to 2.857 seconds. So now we found the time of flight. So this is the time it takes until the ball lands. And basically the reason we can easily get that is because we've used now the height of the taller wall until the ball lands. Alright, so now next we need to find the total horizontal displacement of the ball to find the value of B. So we're going to use the formula x is equal to ut. Because we now know the total time of flight, we're going to use that 24.5 times 2.857. So B shall be equal to 70 meters. So now we know the total horizontal displacement. So now that we know that, to find the distance between the small tower and the point where the ball first lands, we're going to have B minus A, which is 70 minus 35, which is equal to 35 meters. And therefore, the distance between the small tower and the point where the ball first lands is 35 meters. Alright, let's look at another unique example. So I've been told in number 6 that a batsman strikes a ball horizontally when it is 1 meters above the ground. The ball is caught 10 centimeters above the ground by a fielder standing 12 meters from the batsman. So find the speed with which the batsman hits the ball. Now when you read this question, basically the key term that is new is that fact that the the ball is caught 10 centimeters above the ground by the fielder. So that's going to be very important to solving this question. So let's sketch this. So basically this is our fielder right here catching the ball at some distance above the ground. So now basically this is what we have. So now basically the batsman has hit the ball when it is 1 meters above the ground, and that actually stays the same. So basically right now we're going to also illustrate the height above the ground from which the ball is caught, and that 10 centimeters is the same as 0.1 meters, and that's why we have that there. So now basically now we can also see that the horizontal distance from where the batsman hits the ball to where it is caught is 12 meters. And then we don't know the initial velocity, and then that is going to be the v value. Now basically our horizontal motion is basically in this region right here. So basically that means that when we are solving this, the y value that we're going to be using in our calculations is basically going to be 1 minus 0.1, because we'll be considering the height or the value of y from this point to that point only in this case. Alright, let's solve that. So now we find the time of flight of the ball. So the time of flight is basically the time it moves from here up to the point where it is caught, and that we're going to find, but from the formula y is equal to a half gt squared. Now we know the y value is going to be 1 minus 0.1, which is 0.9, and basically we substitute that inside there. G is 9.8, then we'll have 0.9 being equal to 4.90 squared. So t squared is equal to 0.1837, and then t is going to be the square root of that, which is equal to 0.42857 seconds, and that's basically our time of flight. So now that we know the time of flight, we can find the speed the batsman hits the ball, which is going to be the velocity u. So now from x is equal to ut, we know that 12 is going to be equal to 0.42857 u. And then when you divide, so when you get u, you make it the subject. 12 divided by 0.42857 is going to be equal to 28 meters per second. So therefore the batsman hits the ball with a speed of 28 meters per second, and that is the answer. Alright, let's move on to another unique one. So I've been told that a vertical tower stands with its base on horizontal ground. Two particles A and B are both projected horizontally and in the same direction from the top of the tower, with initial velocities of 14 meters per second and 17 meters per second respectively. If A and B hit the ground at 2 points 10 meters apart, find the height of the tower. So now basically in this case we are looking at two particles being thrown from the same vertical tower. So how are we going to sketch this? So we're going to draw one vertical tower, as you can see there, and then we're going to have two particles being projected from the same tower. So the height of the tower is going to be represented by y, which is there, and then the initial velocities, since basically we can only use one straight line because we're dealing with horizontal velocities, so now we're representing the horizontal the initial velocity of A, which is UA, which is 14 meters per second, and then UB is going to be equal to 17 meters per second. Now we've been told something key, that if A and B hit the ground at 2 points 10 meters apart, so we've been told that they hit the ground 10 meters apart, so being asked to find the height of the tower. So now we can actually see that now A and B are going to be 10 meters apart. So now XA is going to be representing the distance or the horizontal displacement of the ball A, actually particle A, which is from here to here, and then we're also going to have to represent the horizontal displacement of particle B, which is going to be represented as XB. So now I think it's very clear. You can actually see that XB is going to be equal to XA plus 10, which is basically clear as you look at the illustration. So now we can see that XB is equal to XA plus 10, and that's going to be very key in our calculations. So from the question you can see that the times of flight of the two particles T are equal. So the particles actually land at the same time. So for particle A, let's deal with particle A. So for particle A, we can actually see from x is equal to ut that we can have xa being equal to ua times t. So therefore xa shall be equal to 14t, because we know what ua is. And therefore we can have this as our first equation, that xa is equal to 14t. And then for particle B, we can also use the same equation, x is equal to ut. We can actually set xb shall be equal to ubt. So xb shall be equal to 17.5t. But now this is where something very important comes. We remember that we noted that xb is equal to xa plus 10. So therefore xa plus 10 is equal to 17.5t. Then when we make xa the subject, xa shall be 17.5t minus 10. And then we shall have that as our second equation. So now we have two equations that actually have xa being the subject. So now we can equate equation 1 and equation 2. So when you equate the equations, we have 14t being equal to 17.5t minus 10. So we're going to collect like terms. So 10 is going to be equal to 17.5t minus 14t, of which we have 10 being equal to 3.5t. So when we make t the subject, t shall be equal to 10 divided by 3.5, which is equal to 2.857 seconds. So now we have the value of t, or the times of flights of the two different particles. So now that we know the time of flight, we can find the height of the wall. So now to find the height of the wall, we need to find y. So we're going to just replace that and put the value of t. So y shall be equal to a half times 9.8 bracket 2.857 squared. So y shall be equal to a half times 79.992, which is equal to 39.996 meters. But this is approximately equal to 40 meters. So therefore the height of the tower is 40 meters. And that is the answer we're looking for. Alright, so moving on to another question. We're being told that O, A and B are 3 points with O on level ground and A and B respectively 3.6 meters and 40 meters vertically above O. A particle is projected horizontally from B with a speed of 21 meters per second, and 2 seconds later a particle is projected horizontally from A with a speed of 70 meters per second. show that the two particles reach the ground at the same distance from O and find this distance. So now we're going to first have to sketch this. So now we're being told that we have particles OA and B. So now basically we shall see that A and B are actually, the best of illustrating them is like having them coming from the same tower, where A is 3.66 meters above and B is 40 meters above that tower. So now basically we can actually see that the initial velocity of B is UB, which is 21 meters per second, and then the height of UB, the height of particle B shall be represented by YB. Then the initial velocity of A shall be UA, which is 70 meters per second, and then its height above the ground is YA. Now there we can place the point O. So the point O is on the horizontal ground somewhere. And now basically what we have to do is to show that these two particles reach the ground at the same distance from O. So now we've illustrated it this way, that now let's assume that they actually land on the same spot, because that is the only way they can actually be the same distance from O, and then we're going to actually know the distance that they are from O. So now basically we can actually see that XA, which is the distance covered by the particle projected from the point A, shall be represented by XA, and then also the particle, the horizontal distance of the particle projected from the point B shall also be represented by XB, having that as the horizontal distance. So now basically the proof we're looking for here is we just have to show that for the two particles A and B to reach the ground the same distance from O, we must have XA being equal to XB. So that is basically the proof that we need. We have to prove that XA shall be equal to XB, because once that is true, it basically means that they are actually the same distance from the point O. So let's deal with the particle A. For the particle projected from A, so let's deal with this. From y is equal to a half gt squared, we can actually see we're going to first find its time of flight. Let's first find its time of flight. 3.6 is equal to a half times 9.8 ta squared. So ta shall be representing the time of flight of this particle. So ta squared shall be equal to 0.7347, of which ta shall be equal to root of that, which is equal to 0.857 seconds. So that is the time of flight of particle projected from point A. Alright, so now from x is equal to ut, we can find the horizontal distance covered. So xa shall be equal to UA/TA. So we just have to put in the time of flight that we've just discovered, and then we shall multiply it to the initial velocity of particle projected from point A. So we shall have xa being equal to 70 times 0.857, which xa shall be equal to 60 meters. So that is the horizontal distance covered by the particle projected from the point A. So now let's deal with that particle projected from B. So we're also going to say from y is equal to a half gt squared, we're going to find the time of flight of that particle. So we have 40 being equal to a half times 9.8 tb squared. So tb is representing the time of flight of the particle projected from B. So we have tb squared being equal to 8.1633, of which tb is square root of 8.1633, which is going to be equal to 2.857 seconds. So we have that as at the time of flight of the particle projected from B. So from x is equal to ut, we can find the horizontal distance it covers. So xb shall be equal to ub/tb. So we have the time of flight of that particle times its initial velocity. So it's going to be 21 times 2.857, which xb shall also be equal to 60 meters. So now we see something identical in both sides. So therefore, since xa is equal to xb, it therefore means the two particles land the same distance from O, and that distance is 60 meters. Alright, so moving on to question number 9, we're being told that A and B are 2 points on a level ground. A vertical tower of height 4h has its base at A, and vertical tower of height h has its base at B. So when a stone is thrown horizontally with a speed v from the top of the taller tower towards the smaller tower, it lands at a point where ax is equal to 3/4 ab, 3/4 of ab. When a stone is thrown horizontally with speed u from the top of the smaller tower towards the taller tower, it also lands at the point x. So being told to show that 3u shall be equal to 2v. So let's first sketch this in our solution. So now we have two different points. So there's going to be a point A and there's going to be a point B. So now we have the point A right here. So this is the point A, and then that point A, the vertical tower at that point is of a height 4h, and then this is point B, and the vertical tower there is of a height h, while here it's 4h. So now we can say that the initial velocity of the particle from point at base A is actually projected with a velocity of v meters, as we are told in the question, and then meters per second and then that from point B is projected with u meters per second. Then we have also been told something very important, that with the speed v from the top of the taller tower towards Mars, so it lands at a point where ax is equal to 3/4 of ab. So now we can actually see that ab is this horizontal distance. So now this distance until this particle lands is going to be 3/4 of ab. So when a stone is thrown horizontally with the speed u, so this is the one from point B, it also lands at the point x. So that means it lands at the point x also. So that definitely means that the remaining distance is 1/4 of AB. Alright, so for the particle projected from A, we know from y is equal to 1/2 gt squared, we're going to actually first find its time of flight. So we have 4h being equal to 1/2 times gta squared. So we're going to leave the g as it is. We're not going to put 9.8 there. We're going to just leave it as an unknown, and we're going to find what the time of flight is. So the time of flight ta shall be equal to root of 8h over g. And then from x is equal to ut, we can find the horizontal distance covered by A. So we'll have 3/4 of AB being equal to VTA. Remember, in this case, for the particle A, we've been told that its initial velocity shall be represented by small v. So we're going to substitute that where we actually have the u. So now we're going to work and strive to make AB the subject. So as you can see, we remember that TA was equal to root of 8h over g. So we're going to substitute that there. So now AB shall be equal to 4 over 3v times root of 8h over g. So that's going to be our equation 1. Alright, so for the particle projected from B, we're going to have from y is equal to 1/2 gt squared. We're going to first find its time of flight also. So h shall be equal to 1/2 times gtb squared. So tb squared shall be equal to 2h over g, of which tb shall be equal to root of 2h over g. So now from x is equal to ut, to find the horizontal distance covered by B, we shall have 1/4 AB being equal to UTB. So now we have 1/4 AB being equal to U times 2h over g. So now remember that its initial velocity here was represented by u, and that's why we keep it that way. And tb was equal to 2h over g. So now we're going to make ab the subject again, and we're going to have ab being equal to 4u times root of 2h over g. So now the next step is going to be to equate equations 1 and 2, because now we have ab represented in two different ways. So now we're going to have 4 over 3v into root 8h over g being equal to 4u into root 2h over g. So now basically you can simplify it the best way you want, but I feel it's better to first square both sides to eliminate the root, because in our final proof there are actually no roots. So when you square both sides, we'll have 16v squared over 9 into 8h over g on the left hand side, and we'll have 16u squared into 2h over g on the right hand side. So now basically the next step we can actually do is we open brackets. 16 times 8 is 128, so we'll have 128hv squared over 9g being equal to 32hu squared over g. So next we can cross multiply to make this easy, so we'll have 128hgv squared being equal to 288hgu squared. So now this is basically what we have. So now we're going to divide both sides by 32hg to actually simplify this further. So when you simplify it, we'll have 4v squared being equal to 9u squared. Now, the next step we can do is that we can also find the square root of both sides. So finding square root on both sides, we'll have root 4v squared being equal to root 9u squared. So we'll have 2v being equal to 3u. And therefore, 3u is equal to 2v, and that is the proof they wanted. Alright, so lastly, I have an exercise for you that you can actually try out. So these are several questions. I've actually placed the answers right to them. You can actually try it out. So you can actually pause the video and copy the questions and try them out to make sure that you get better at this part of horizontal projection. So these are several numbers. This is question number 4. We move on to question number 5, 6, 7. This is question number 7. Then there is question number 8, 9, and question number 10. So just try this out and get better at your knowledge of horizontal projection. Otherwise, thank you so much for watching. Thank you so much for watching this video. I hope the video really helped you. If you did, feel free to tell me below in the comments. I'll make sure to get time to read through your comments and to reply to you. And also, if you're new to this channel, I encourage you to join the community by subscribing. And then make sure to hit the notification bell so that you get updated every single time I upload a new video. Again, my name is Emmanuel Olega. Thank you so much for watching. See you in my next video.